Hey guys, this is my LAB1 report for the charged tapes. The problem of this lab is that we have two charged U tapes, tape A and tape B. They are both under the effect of gravitational force. They will exert electrical force on each other, and our goal is to estimate the amount of charge a U tape needed to float above the others. Notice here is that we will treat both the U tapes as point particles, which I will mention more in the following slides. The physical principle used here is the Coulomb's law, which is the electrical force equal to the K times QA times QB divided by R squared. Because we assume that here A and B have the same charge, so that QA times QB will be converted to QB squared, and use this formula we can calculate QB. And here's the result. This is my section previews. For my experimental model, the pre-knowledge that I have already know is that tape A and tape B, they will repel each other because they have the same material and they are likely charged. The design of the experiment is that we will treat tape B as the system and we will treat tape A as the surroundings. Because the net force will be equal to 0, so the magnitude of the gravitational force and the electrical force will be equal. The lengths of the tape, as I measured, are both 0.0 meters. And use this length, we can calculate the tape mass be 0.2 grams, and then we will convert it to the kilogram form. The distance will be 0.04 meters. The electrical force will be equal to the gravitational force, and it's 1.968 minus 3 newtons. Use the Coulomb's law, we will calculate the charge of the B. And the charge of a B divided by the individual charge of an individual electron, we will calculate the number of the electron. We have already know that the molecule length scale is equal to 1e minus 10, and we will use this to calculate the ratio of the molecule that have the charge, which is 58.3. Here's my computational model. First, I give the constant, and then I treat tape A and tape B are 2-point charge, and the only difference in their position is in the Y component. And then I build the initial condition for the R. R is equal to the system position minus the surrounding position. As I have the computational, I have the calculation is here. Is that I use that function to calculate the B charge by the change the form of Coulomb's law. On the right side is my result of when running the code. To estimate approximate amount of the charge on the floating type B, we have to make some assumptions. First is that although B will float a little bit upward, but we will ignore air resistance on floating the tape B. And we will treat both tape A and B as point charge, as I had already mentioned. And third is that each tape, they have the same amount of charge and they are evenly distributed. That is our assumption. Here's the answer to what if and why question. First is what if electrons positively charged and protons negatively charged? I think there's no change to the interaction of the tapes, because although that the electrons and protons exchange their charges, they are always likely charged and will still repel each other. Another example is that tapes will originally attract to the charged plastic pans because they have the opposite charge. And when you change the sign of the electrons and protons, they still have the opposite charge, so that they will still attract each other. The why question is why it's important to handle the charge as little as possible. I think it is because that the hand and the tape are oppositely charged. When you use your hand or fingers to contact it with the tapes, the electrons will transfer from one to another, which will change the charge of the tape and will making the result to be inaccurate. Here's my conclusion. Generally, the result produced by the experiment is perfectly matched with the computational model, but there are still things to need to be improved. First is that The output charge of B is actually a highly approximate result. The result could be affected by the surroundings like my hand, and the measure of the distance that the tape B starts to flow up is not accurate enough. Thanks for listening.